Greetings, you've landed at the VUC, IP Communications and VoIP community. We would like to thank Simwood.com for their support. Simwood can turn you as a developer into a telco. Our hosted PBX is from onsip.com, and you can go to getonsip.com for a URL people can click to call you. We've been privileged over the last 5 years to be using the best conference bridge on the planet. Yes, I'm talking about zipdx.com, full color, full featured, full HD conference bridge. Our website, VUC.me on the webs, hosted by Bluehost.com. And our worldwide local rate dial-ins are from Voxbone.com. Emil, why don't you say hello?
Hey, everyone. Good to see you. Very good to be back here. Thanks, Randy and Mike and everyone for having me.
Emil, tell us briefly about the birth of Jitsi, including the SIP client and all that. What year are we going back to? 2008 would be a guess, but maybe I'm wrong.
Everything started, Jitsi started 13 years ago. That's quite a long time. We've been at it for quite a while. We started as a soft client. It was a SIP client. Started as a prototype project, a student project actually. Then it became a popular one. People were contributing more and more. We added other protocols. We added support for conferences. At one point we said, well, we actually used to be called SIP Communicator back in the day. And
that's right.
At one point we were, well, we're not anymore a SIP only communicator. Now we do a bunch of other things. So let's change the name. That's when we became Jitsi. And in about 2013 actually, we started this video bridge effort. Jitsi could do conferencing for quite a while. It started with audio conferencing, and it was actually acting as the host. However, contrary to most clients, it wouldn't limit you to just 3 participants. It would take as many as necessary, as many as you wanted, as many as your computer could support. And while we were doing this with audio, we thought, well, that would actually be a great idea to also add video support to it. So we couldn't do an MCU, obviously, because we wanted this thing to be able to run on generic commodity hardware that people had. So that's how we got into the video routing space. And that's how Jitsi became an SFU, a selective forwarding unit as well. And then the next step was, you know what, we rarely have enough bandwidth to do that on a client. Why don't we take the video routing parts of Jitsi out and put them on a server? And this is how Jitsi Video Bridge was born, which is what we're using today for this conference.
And we started experimenting around, I don't know, 3 or 4 years ago.
I think the
first test.
The first test we did with Jitsi, it wasn't with WebRTC, but we were hosting the Jitsi video. We were using the Jitsi Video Bridge. I think that was 2012, maybe. And then the first WebRTC-based ones that we did were in early 2014, very early 2014.
I know that looking at the statistics, the original Jitsi conference that we did, where you had Jana and about 3-4 other people on, we had like 6 of your team on, maybe even everybody was on. That is one of the most watched videos of all.
That's great.
Probably because of Jana, but let's pretend
it's
because
I remember that one. That's the one where Jana was sitting on the ornate couch right in the middle, and and it was brilliant because it's a really good way of showing how good the high definition video was, because you could see, well, Jana.
Right.
I'll shut up.
No, you don't have to.
See, I can't see myself when I come on the screen. So, oh my God, it's Tim from place out west.
Indeed, Reno.
Hi, Tim.
Reno 911.
No, not yet. It's not that bad.
And how are you connected, Tim?
I tried LTE, but I couldn't get enough bandwidth out of it, I'm afraid. So this is, and the screen was too small.
All right.
See what I'm doing?
Well, just don't tell anyone whose service you're using. Then clearly
AT&T
rubbish.
AT&T's, obviously.
Okay, so this
Well,
is a
that
different
killed that
setup
one,
for
didn't
everybody.
it?
Yeah, we're using a different setup. However, I would like to say that and now I see that my video has gone to hell because I am actually on LTE.
Actually, your video is still pretty good. You're sending 540p,
Okay.
which is almost HD.
You know, it's a little confusing. Sorry for the inside baseball folks who are listening, but it's a little confusing to not have the film strip. I wouldn't want it on YouTube, but it's handy to have it here. And the reason is because I can't tell what I look like. And that's why I had a slide on forever. And then it looked like an avatar. And I still see that avatar. But I'd have to bring the film strip up, which I can do with the F key, right?
Yes.
There we go. So that avatar wasn't me. All right. Enough of that. Why don't you introduce Aaron and have him say hello?
Yeah, I'm actually very happy to do that because Aaron is one of the people who joined Jitsi after we joined Atlassian, and we are incredibly lucky to have him. As many of the other team members, Aaron is very, very experienced, very smart. He's actually responsible for a lot of the work behind what we are using right now to stream to YouTube. He's also responsible for the infrastructure that's running it. And he's been able to find very creative and smart solutions to many of the problems that we have to make this pretty much one of the most advanced WebRTC streamers out there in the market. So Aaron, very glad to have you in our team and on this call. So the VUC has a tradition to ask newcomers how they got involved in computers and in IT in general. What's your child story?
All right. Well, I was born at a very early age and proceeded to pretty much be interested in computers my whole life. By the time I was 10, I had already learned Perl. I don't admit that anymore, so we're just going to leave that right here between us here on YouTube. I've also been involved with a lot of open source projects over time. Involved with Mail, PHP-based. I wrote GPG plus G plus that. I've also been involved with the XRMS CRM project, and that kind of helped me get deeper into the business side of open source software. I then dropped out of that for a long time until I got hired by Atlassian, who wanted me to work on Jitsi. So my back experience for DevOps and systems administration, I've done pretty much everything from working in manufacturing companies, working in small businesses whose sole role was to deliver quiz games to people. And also I've done a bunch of vending machine management systems. I also worked on the Large Hadron Collider project at the University of Chicago, where I managed a data center which was storing multiple petabytes of data with high energy physics. So I've pretty much been all over the place. And I've been a technology enthusiast my whole life. And when I got to work on this video project, I was extremely excited because I get to combine pretty with technology. And usually I'm on the back end, so pretty just doesn't come into it, except maybe an elegant solutions. Less so actually getting to show somebody else who doesn't know anything about computers something cool. So I've been pretty proud to get to be part of something like this. And I guess that's me.
That's excellent, Aaron. Really happy to have you among us. And as I would extend this welcome to most people who are the first time on screen, you're certainly welcome to stop by and hang out. And if there's topics, you know, it doesn't have to be Jitsi, but if there are video topics or other things you're interested in, you should join the panel with us because we love to have people who know what they're talking about, unlike me, who doesn't. Now,
not true.
And this is a perfect segue because, Emil, I would like to bring this question that I asked you out in front, and then we can take it wherever you want to go. But my question was, I called you on the Simulcast post you made because in the broadcast, and Michael maybe will second me on this, Simulcast has a meaning in broadcast TV that has absolutely nothing to do with what you're doing. So can we clear that up? Michael maybe could give us his definition of Simulcast that has nothing to do with WebRTC, and then you can explain this.
I think the meanings are similar. I mean, the classic simulcast is when a television station would be broadcasting, say, a live concert event or something like that, and a radio station would have a simulcast of that, so the audio stream would go out by radio and the video would be available by TV and all that. So that's the classic simulcast model. But I think there are parallels there, and I'm sure that Emil is going to enlighten us in this regard.
So that's really very interesting. When you told me, well, Emil, actually simulcast has been a word that's been used for quite a while in a somewhat different way that what you're using it for. And I was really surprised because I had never heard that. And I gave you the incredibly weak argument of, I'm sure my father wouldn't know your meaning, which is not a great example because my father wouldn't know either meaning. And as you said, he hasn't grown up in the US. So I was curious that, I mean, I found it very curious that it had such a popular meaning, and that is entirely unknown to me. So, but I guess it's just a generic word that just means simultaneously sending multiple things. Okay.
Simulcast, a portmanteau of simultaneous broadcast, is the broadcast of programs or events across more than one medium or across more than one service on the same medium at exactly the same time.
So because Google is against me this time, and I'm going to make the snarky command of course, if Google says it, it must be so. But in all fairness, it has become a pretty popular word in video streaming in the past several years. And here's what it's meant. I have this diagram here. But let me take a step back and say this. In general, when you're doing video conferencing, we've been through this many times in our previous editions, but you have multiple ways of doing it. Like there's the amateurish one where you're basically trying to connect everyone to everyone. You have no infrastructure. That sort of works for a few participants, not really for more than that. Then there's the conventional approach, which is the MCU that acts as this big server in the middle that takes the video streams from everyone, decodes them, scales them down, creates composite images, and sends them back to the client. So every client has the impression that they're only getting one single stream. And then as we evolved, as bandwidth restrictions changed, this new approach came into play, which is the video routing or the selective forwarding unit approach. The first people to promote that were companies like Video, Google Hangouts, who were originally using video and then changed to their own implementation, and also Jitsi, which is Video Bridge, who was, I believe, the first open source implementation of an SFU. But I might be wrong. I'd be happy to be corrected. So the thing with an SFU, the thing with a video router, is that when you're sending stuff, you're not modifying it in any way. You just resend whatever you got from everyone else. And people would often say, wait a second, so if I'm on a mobile and there's 5 other people sending HD on this call, you're just going to flood me with their HD streams on my mobile device? Are you insane? And this is where simulcast comes in, actually. So the whole point is to say, we're on a router. We don't get to touch the video streams, so it's hard for us to adapt that way to what receivers can actually get. So why don't we outsource our heavy lifting to the senders and tell them, hey, you guys should be aware that there might be less powerful receivers in this call. So just in case there are, make sure that you're sending us multiple resolutions and multiple streams, and then we'll pick and resend the ones that actually make sense. So here's this diagram that I have here. Simulcast basically means that you take the same video source, you encode it several times. Very often that would be 3. You would have a small resolution, a middle resolution, and a high resolution. That's what every sender here on this call is sending to the video bridge. And then the video bridge looks at that and says, first of all, who is everyone? Who are people watching? Emil seems to be watching Randy. Randy seems to be watching Emil. So I'll make sure that Randy gets Emil's high quality stream and the low quality stream for everyone else, because I know that everyone else is just being rendered as a thumbnail to Randy. So Randy doesn't really need to get HD for the other participants. And then it will make similar choices, but not necessarily the same for everyone else. And that's important because getting that amount of flexibility in a video mixer is very hard. It basically means that you have to encode your stream differently for every receiver, and very few MCUs do that. because it's incredibly expensive. An SFU, that's just out of the box, almost. So the receiver would still have the impression that they're only getting a single stream, but that stream would change in resolution depending on who they're watching, and then also depending on how much bit rate they can afford to receive. And that, in a nutshell, is what simulcast is in the WebRTC world. And I do surrender. I acknowledge that the other meaning has been around for longer. So I'll make it clear from now on for which simulcast I'm talking about.
So no millennial would no millennial into WebRTC would ever have heard of simulcast, but anybody else would actually know.
Let me bring to this a question then. Explain to me, if you would, where simulcast fits with scalable video coding, or SVC.
That is a great question. They are essentially achieving the same purpose. They have advantages and inconveniences. Scalable video coding is actually, well, I even have diagrams for that as well. So why don't I get back to my slide deck? So scalable video coding essentially gives you the same layering, and its purpose is, again, to allow the video bridge in the middle to send whatever each receiver can afford or needs to get. So there are several ways of doing simulcast. The first one is spatial simulcast. What we see here is a very low quality image. For example, that would typically the base lowest quality layer of a spatial SVC stream. Now, as you, is that an important message on the background? Not seeing the screen share. Are you guys seeing the screen share?
Yes,
it seems to be on YouTube. So, you know how sometimes when you download images over the internet and they would first show in a crappy resolution, and then gradually they would improve and improve and improve as more data arrives, and that completes your image to a better quality. This is exactly what the upper layers of SVC do. So instead of them being entirely independent streams, they're actually just the deltas between the low quality and the high quality and the HD quality. So at the end of the day, you just, with spatial SVC, you pretty much get the same the same functionality as with simulcast. Now, the advantage of SVC is that it takes less bandwidth because you're not resending, you're reusing a lot of the information that we use to encode your base layer, and you're only sending deltas. So on average, and these are numbers that Alex from Video often shares, on average, you would get a 20% more bandwidth usage with simulcast and a 20% more CPU usage with simulcast in certain scenarios. Now, the advantage of simulcast is that the streams are completely independent. What that means is that, for example, you're not bound by constraints that you have in SVC, for example, where you can't just encode any resolution for the middle layers. There are certain rules that you have to respect. So you basically go from 360p to 720p to 1080p, and that's pretty much it. You cannot just go around with different resolutions. With simulcast, you can have one layer that's 90p and one layer that's 1080p, and that can be all of it. And in that case, actually, your bitrate consumption and your CPU consumption with simulcast will be lower. So in general, I would say that they both have their pros and cons, and I would consider them equivalent in terms of what they deliver to people actually deploying services. And there's actually another way of doing spatial video, of doing SVC, and that's the temporal scalability. Temporal scalability, again, you have a number of layers. However, instead of changing the resolution as you go up the layers, you simply increase the frame rate. So on the lowest layer, you have 7.5 frames per second. Then the upper layer just contains the frames that would bring that up to 15 frames per second. And then on the third layer, you'd have just enough frames so that you would get to 30 frames per second. And again, the dependencies here are strictly downward. That is, all the frames that are on the middle layer would only be deltas to images that are on the base layer or on the same layer as themselves. Nothing will depend on the third layer here, which means that an SFU, a video router in the middle, can choose to drop any of those depending on what the receiver can handle. And Today, probably one of the most widely used simulcast implementations, which is the Chrome one, actually gives you 3 simulcast layers, 3 resolutions on simulcast, and then within every simulcast layer that we're sending right now. Hey James, could I please ask you to maybe mute? Thank you. So these Apple headsets are so good that they do such a good volume that they actually send it back to their microphone. So anyway, with Chrome, you get 3 resolutions on simulcast, and then every simulcast stream that we are sending currently in this conference is actually containing 3 temporal layers as well, 3 frame rates. So in theory, the bridge in the middle can play not only with the simulcast resolutions, but also choose to play with the frame rate depending on what the different participants can handle. In Jitsi Video Bridge, however, we are only using simulcast for now, and playing with the temporal layers will be one of the next things we do in the near future. Does that answer your question, Michael?
Yeah, it does, and I think there are different ways of achieving similar things. If you were to point to somebody, where's the benchmark implementation of SVC or the reference implementation? Do you think? Who do you point to as being sort of the leader in that space, or do you know?
So Video are certainly very popular with their implementation of SVC. They're among the first that started to exploit that direction, and they pioneered a lot of the approaches that are being used. Since then, others have followed. Polycom have an SVC implementation that's independent of Video. VP8 has had a temporal SVC implementation for quite a while.
And all these others have been H.264, though, haven't they, to this point?
Except for Google's VP8 one, which is VP8.
And it's in the 8 part of VP9, right? It's
VP9 also has the temporal scalability, but Video contributed spatial scalability for VP9 in addition to the temporal scalability. So, and that's already deployed. That's already finished in terms of code. However, it is not yet available in Chrome, as far as I know. It's not yet enabled. It's enabled in the decoder, to my knowledge, but not in the encoder just yet.
Cool, because in that conversation, we've completely circled the wagons around all the common video codecs, certainly all those that anybody concerns himself with at this point. So that's wonderful.
Right. Yes. Exactly. So getting to support simulcast in the Video Bridge was a pretty complex exercise for us. We went about it in different ways. We first tried to handle it fully on the client. Then we decided that was too complicated. We moved it to the bridge. That wasn't a very easy job to do. It took us a while. We've actually been at it for almost 18 months. It's finally out there. It's finally deployed in production and working pretty well. So I'd like to give a special shout out here to all the people who worked on it: George Polidis, Lubomir Marinov, Boris Grozev, and the entire Jitsi team who helped there.
Great work.
Thank you. So the other exciting feature that we recently added to Jitsi, and I don't want to make this a pony show. So if you guys would like to take the discussion elsewhere, please let me know. But I think it's worth mentioning that we added this other feature, the live streaming, that we're currently using in order to stream VUC on YouTube, and I assume that's how many of the VoIP of the IP communications community members will be watching this call. So we finished this recently. We've released it recently. We're just about to announce it. I actually just wanted to have the VUC call as something that we can refer to as an example. So we're going to announce that probably as soon as the recording is out. But recording and live streaming is something that we've wanted to do for a while. There are a bunch of ways you might want to do live streaming. There's a bunch of reasons why you might want to do recording. As typical engineers, we started looking at recording the right way. What that would mean is we're thinking, well, all the packets are going through the server. Why don't we just take the VP8 out of the packets as they're going through the server and then put it into WebM files? Because that's, VP8, WebM, sure, it makes sense. We record them separately. We record all the audio separately so that we have all the source data and we can use it in fancy ways after that. And then we'll have a post-processing tool that goes and takes them all and combines them and creates one single recording. Now, again, this is the technically right, proper approach. And it's been very hard to get it where we want to. So this is how our JIRICOM project, this is what our JIRICOM project tried to do. It worked, actually. It was a pretty good piece of code. However, it was very hard to maintain. There was a lot of change on the WebRTC side of things that we had to adapt to, and that wasn't even the hardest part. The hardest part was that the post-processing project that we had would basically take all the videos and try to lay them out in a similar way that they appear in the conference. And that actually means pretty much re-implementing every single feature that you have in the conference in your post-processing tool. That's one thing, that's a lot of work. Secondly, it's not real time. Okay, you basically finish your conference and then you have at least as much time as the conference lasted in order to get your actual decoding. But we were thinking, you get great quality because you haven't been constrained by the real-time constraint, and you can now process your video exactly as it was encoded by the clients. There's no loss that's due to a real-time constraint. Well, it turns out that this was overly theoretical because we recently started this alternative approach, which is to basically say, why don't we take one of the participants in the conference and make that the recorder? So it's a virtual participant, and I'll actually let Aaron explain more about how Jibri, our new recorder, works. But the benefit of that is that you basically get real time, which is why we can actually live stream it. You get a recording, and the quality of that recording is actually pretty comparable to what you're seeing in the conference, at least with the as a user, I don't really see a difference between the two. And I'm going to let Aaron talk a little bit about how Jibri works. Just one final point before I pass the mic to you, Aaron. Everything that we're doing here, including all the stuff that we did since we became part of Atlassian, is open source. So hopefully, although all of this is available on Meet Jitsi and people can go and use it there, we're actually hoping that people will download it and run it as for their companies or for their communities. Everything that Aaron will be explaining now is actually open source and available to everyone to use. Aaron, I'm leaving it to you.
Well, first of all, I wanted to give Randy a chance to weigh in if you guys have any other questions or comments about what we're about to talk about some more. Otherwise,
no. We first got to finish our pitch. Don't give them a chance to interrupt us.
But we'll get to it afterwards, Aaron. Go ahead. This is great.
Okay, great. So basically, Jibri is a service that's written in Python. It's basically at least the control layer is, and it basically connects into the XMPP server where all of the services are running, and it notifies the focus to let it know that there is a Jibri available. Then that Jibri then the focus communicates to all of the Meet clients, just like we have here, whether or not a recorder is available. Once a recorder is available, there is a live streaming button that appears in the Jitsi Meet interface. When you click that button, you are able to enter a live stream ID. Now, this is the ID that YouTube gives you for allowing incoming live streams that YouTube will then rebroadcast. So then the user enters in their live stream, and that live stream ID gets sent to our focus, and then eventually gets sent back to one Jibri. So basically, the focus chooses a Jibri to start the recording. And so what the Jibri does is it takes this ID and it launches an instance of Chrome within X11. So basically, Jibri is running on a separate server. It runs Chrome. It then waits and connects to the conference that has been requested, authenticates to the server to make sure that it's actually coming in as a trusted recorder, and then finally launches FFmpeg, which records the video from the Chrome as well as the loopback audio that we're using an ALSA loopback device. So the basic idea is we're using existing open source components and kind of stringing them together, gluing them together with this Python controlling agent. And that's what then controls the connection to the conference as well as the beginning of the stream. And then mostly that just watches and makes sure that the stream is still alive, that the Chrome is still alive, and then sits back and waits while your stream streams to YouTube. Then we just wait until we get a prompting from the user to say stop live streaming, or on the free service, if it's been an hour, we'll cut you off anyway. And then we basically shut down and we wait for the next call to start live streaming again. We basically implemented this on Meet Jitsi, but it's also connected here on Jitsi VUC592. And we basically have a pool of Jibris that allow recording of any conference that are happening on our platform. So that's the long and the short of it. Any questions so far?
There is a question on IRC, but it's a little hard to read, unfortunately, because there's some links. I don't know. Were you able to get on IRC?
I've not yet gotten there. I was working on adding it in the background.
So I didn't understand. Why is it hard to read?
There's a few people who are really geeky enough to be talking on IRC and talking on the screen at the same time. But
okay, here comes the question: Does Jitsi use Dash? Use the Dash ISO standards for adaptive streaming? Yeah.
Okay, so that's actually a good question, and it's important to. I've often been asked that same thing, so it's important to make a distinction here. Now, if you take a codec, it basically just takes a stream in and puts a stream out. So what it's I'm summarizing here and potentially a little bit grossly, but a lot of the changes that we're talking about here, about layering, about Dash, these things happen later into what's called the packetization on containerization. So the Dash packetization is something, for example, with Simulcast or SVC, is something that's meant for real-time communication. Dash and HLS in general, they're meant for just streaming, but not necessarily real-time streaming. And yeah, I know that live streaming might sound like real-time, but it's not exactly. It doesn't have the same constraints. It's not bidirectional communication. So something like 10 to 20 seconds of delay is considered tolerable there, and it's not considered acceptable, obviously, in a conference scenario. So to put this, to say this another way, Dash is pretty much similar in the idea that it does to Simulcast and to SVC, but it is not the same thing. It's a different containerization, and it's only used for live streaming because it's not adaptable to real-time conferences. Does that make sense?
Yeah, it lives within a different set of constraints because it's a different application target.
Exactly.
I should say that there are parallels in the realm of audio where, traditional audio codecs, G711, G729, what have you, they didn't include things like error correction or packet loss correction, this kind of stuff. Those were all considered layers that were wrapped around the codec, whereas now you've got a lot of functionality built into the codec. The role of the codec and its bridge into transport, if you will, have kind of shifted as we come into the future, right?
That's actually a great parallel. For example, if you take forward error correction for Opus, or at least for the lower modes of the VoIP modes of Opus and Silk, it works in a very similar way. Basically, every Opus or Silk packet will contain the 48 kilohertz version of the audio, and then we'll have a small chunk of data attached to it, which is actually the 8 kilohertz version of the audio. So the point there is slightly different. If you lose one packet, instead of just having a whole, now you have this packet in the one that's coming after it, except that it's in a lower quality. Now, in reality, you would, if it's just one packet, you would never notice the difference and the fact that it played at 10 kilohertz instead of 48 kilohertz. But if you look at it, if you take a step back and look at it, this is exactly the same thing as video layering, even though it's being used in a slightly different way. So yeah, I think that's the parallel with audio is a pretty good one.
Are there other questions anywhere?
So
Aaron is on IRC, so he's. It's so much easier when somebody has questions that are hard to read, because the initial one was a little difficult. So that's fantastic. And if I can just for a second do a commercial for the VUC, this is one of the things that we do really well. But obviously everybody is not always on VUC, on IRC, sorry. So, you know, what I was amazed with when I got into all this was like on Asterisk years, you know, over 10 years ago or so. Emil is moving on his standing desk or something. Is that you could connect with people live who could answer your questions, and IRC has always been great for that, let's face it. But now here we are doing a live video conference. I cringe at the word webinar. This is not what that is. This is a video conference, but people are talking, and Aaron was nice enough to go check that out. And in fact, the questions are kind of like really inside and pertinent usually on IRC. So much for that. Anyway, that's what we do, and we try to make connections. That's what I like the most about the VUC. It's things like this, and we've had the Jitsi, various people on from Jitsi, always with Emil as the anchor for all these years, and I feel like we've done some good work, and he has too.
And I actually would like to echo what you're saying. It is always a pleasure to be here, exactly for that reason. This is where I feel we speak to our colleagues, our co-workers, our I wouldn't use something as cheesy as a soulmate, but you get what I want to say. We get the questions that we're asking ourselves. So it's really it's really great to be able to say, oh, you know what? Yeah, that's a great thing. We asked ourselves the same thing 3 weeks ago. So here's what we came up with, and yes, you have done some pretty good work.
So, but
go ahead, Michael.
Jitsi Video Bridge. If I were to look around, I mean, because I was looking back as we're preparing for this, it's a few weeks shy of 2 years since we first used Jitsi Video Bridge for a VUC call. And back then, it was difficult because we were having to glom together a bunch of different things in some end ways as opposed to, you know, the core ways that you guys have implemented now. This was not nearly so difficult, at least for us, which is, you know, breathtaking. But along in that time, where's it rolled out? Or tell us something about. I mean, we know that you've been successful, but where has that been, or how are you measuring your progress? I guess is the question I would ask.
That's a hard question. So there's obviously a bunch of one of the first things that you would measure an open source project by is adoption. And in contrary to other services, for example, where you would try to measure monthly active users and just simultaneous connections and that sort of stuff. Jitsi Video Bridge is something you download and you run in your environment, so it doesn't really make sense to talk about what's your current load because, well, it's all over the world. How should I know? But what we have seen lately is people coming in the community, some pretty big names that just take the video bridge and use it in their own infrastructure. To give you some examples, for example, Comcast is using that for their share service. High Five are considering, not considering actually, are working on their next release, which will be Jitsi Video Bridge based. There are some other names that unfortunately don't like to be that much mentioned, but even bigger names in terms of numbers of users that are actually taking the video bridge and using it in their services. So this is really,
you know, that's perfect though. That's like, so if you go back to like the early days of Asterisk, right? They used to say, oh, so many millions of downloads or whatnot, but it was, you know, it was a better measure because a download is I fire it up, I play with it, I throw it away. But it's a better measure to say it's actually being taken on board by substantial organizations that are then bringing it to users, which is sort of all you can expect and hope for, right?
Yes, exactly. And there's this one thing actually when personally when I was a student and I was doing my PhD and trying different experiments and then going and publishing papers around them. At some point, I personally became very depressed with the fact that you're just doing your thing and maybe writing a paper about it and maybe you get some comments out of it and that's it. And it didn't feel like I had a good question for myself about the why of all this. Why are we doing it? So back then, I really made up my mind that what I'm going to do with my professional life would be something where I can clearly feel the usefulness of our work. And this is exactly what you're saying, not knowing that there are a bunch of people out there that are using this to solve their daily problems that they have. And it's not life-threatening problems. I don't want to go there. We're not curing cancer or anything like this. But just they have this need during the day and our work actually helps them achieve it. This is incredibly gratifying. And this is what keeps us going.
Well, and yeah, if you get to a point where you have a user base and you have support requirements and you have sort of a mailing list or form or whatever in your IRC channel and you're engaging with your users, it's much as people sort of lament, when you get to a very large scale, people lament customers and sometimes interactions with customers. The very fact that you have them means that you have built a community of sorts. And that oftentimes it's engaging in that community, which is where the payback really occurs, at least on a human level.
Yes.
So. Awesome.
Yes. So maybe one last thing before we end the session, I'd like to say a few words about the things that we'd like to look at next within the scope of the open source project. I'm not saying this for Atlassian, just to make that part clear. We have some pretty cool work planned for adaptivity. Right now, for example, the video bridge, as I said, would adjust the resolution that it's streaming to other people based on who they're watching. It will send you low quality versions for the thumbnails, high quality versions for the on-stage speaker. It would also detect when you don't have enough bandwidth to receive the high layer of the on-stage speaker and circuit break that layer to a lower quality version so that you're not completely flooded and dust out of the conference. Our next steps would include actually ramping back up, and this is pretty interesting because there's a bunch of work to do around picking the best approach to ramp up. In order to ramp up to an HD quality stream, well, you have to make sure that the bandwidth is now available, but while you're probing whether that bandwidth is available or not, you have to try to not, screw up the connection. So there are various ways you can do that. You can do that by adding more forward error correction protection in your stream. So yeah, you might trigger additional losses, but you've overprotected your stream anyway, so it's not such a big deal. There are ways of doing that with padding packets, which is what Google is using, for example. This is going to be, there's going to be some pretty interesting evaluation work involved in that. We also have an ongoing effort on porting all of this to native applications for Android and iOS. This is finally started. People in the community have been asking us for quite a while, and we've been fending off with basically saying that the majority of video conferencing users do it through desktop and laptop computers, but we'd really like to get mobile ourselves as well. We often need to join through mobile. So there's an ongoing effort to take all of the JavaScript code in Meet and make it compatible with React Native so that iOS and Android clients would basically be just using the same code and would be up to date with everything that we do on the desktop side. So we're pretty excited about this. We hope that we would have our first prototypes around end of June, available for everyone to play with. So this is pretty exciting. And
I'm getting excited already, Emil. So as soon as it's ready, can I play with that? Can we play with it?
I will make sure that you have everything at your disposal to play with it, and hopefully maybe even use it in one of your services. That would be really nice. I'm not sure what that is right now, but anyway. Where
I was
did
trying to
that come
show
from?
off the. I wanted to show off the
Okay.
YouTube sharing, but in fact, it's not YouTube. So
Okay. Well, so yeah, we do have indeed the YouTube video sharing feature right now, and we have other things that are coming is we're looking at better device integration, so that when you have room microphones and things like that, you can click on hang up and hang up your conference or that sort of stuff. And then the rest I'm going to keep as a surprise, and we're going to keep announcing things as we go through them. But I hope this gives everyone enough of a taste.
Okay. Do you want some suggestions for some more features?
Yeah, absolutely.
Well, things I would love to see some kind of video agent lurking in there in its own window. So an application that you can call up, a bit like a video Siri or Alexa, lurks in the background in the conference, and then
that would be awesome.
And then you can get it to do things for you.
Well, here's the thing, though. This is something that can be an entirely independent piece of code to Jitsi Video Bridge, pretty much like Ghibli, the recorder is, as Aaron explained earlier. So I think that this is a pretty great idea, but it doesn't need to come from us. It can be implemented.
Well, exactly. Well, your strength is, I mean, you've sorted out all the lower level plumbing and given us a framework that just kind of works reliably, and it's just brilliant. So now it's up to the other people who do perhaps the higher level bits and pieces, the easy bits, to fill it up a bit, fill the framework with some apps.
Yeah. And that would really be a great thing if you can add Alexa to your call and control your home, or add something Alexa-like that would just answer questions or take notes.
Yeah, possibly something a little bit better, which then draws its intelligence from a number of different sources.
That would be awesome. James Alexa, please add Randy to the conference.
Exactly, because I can never remember how to do these things. And then even better, when my wife is a mile away down the road, it'll pop up and say, "Warning, James, your wife is a mile down the road." It's like, I've got to go now. Or, "James, your train leaves in 20 minutes. Just to remind me not to go on too long." And
doesn't your phone do that already?
Well, the thing is, I'm in the Jitsi Video Bridge type environment, and
so what you're talking about is like the TV, the cable, the set-top boxes in the States. I don't know, maybe they must have that everywhere, where you've got your caller ID comes up when you're watching TV and the phone. I've never seen that in Europe,
but
actually.
Slightly better than that. I'm thinking about something a bit like Jarvis in the Iron Man films. Remember, Jarvis puts on his suit. And Jarvis is his kind of electronic butler who helps him. And he's aware of all the stuff going on around in the background, which means Jarvis can get on with all the boring stuff like
Jeff Jarvis,
keeping us on the agenda.
Talking about Jeff Jarvis. Hey,
listen, killing aliens, whilst Iron Man then gets on and does the high level things like working out what cocktail he's going to have.
Okay, before we drift to cocktail choices, Emil and I have been talking secretly on another channel. We need to probably terminate this. We could start another one, though, and that's one of the major things that differs with using an event and Hangouts is that we can start again. Hangouts can never start again. And one of the things that we do here at the VUC specifically is we have our mature audiences thing and we do our private thing. But if sometimes we have double headers where we have two guests, and we would like to do two separate segments, and that's a real pain in the to do. So, because you have to start a whole thing and, redo an event and so on. So in this case, we can just end this, which I'm going to do in just a second after Emil and maybe Aaron finalize. Yeah, you have about 3 minutes left. We will start another stream just to see if we can, okay? But in the meantime, I want to thank everybody for joining us. We will start another stream after this. This needs to be edited because I really screwed it up apparently in the beginning. I did not realize, and I'm sorry. Thank you, Bundini, for great info by Emil, Aaron, and all. So that's very cool. Amy, let me turn it over to you and Aaron, and you can say goodbye, and then I'm gonna press the button, and hopefully we'll stop streaming, and we'll start again. Okay.
Yeah, well, Randy, always a great pleasure to be here and to see that lovely crowd. And looking forward to one of the next editions where we'll have the Phoenix Audio person to talk to us about interesting audio things. Again, thank you, and see you soon.
Okay. Aaron, thank you very much for joining. Please do come back with us on any topic you like.
Thank you very much.
Okay, and thanks to everyone who joins us. We are going to be back next week. By the way, we have no guests next week, I think. Did you sign those folks up for next week, Michael, or is it another date?
No dates yet, but we'll get there.
Okay, so we don't have anybody for next week. So, hey, if you're watching this and you'd really like to be part of this, I can't imagine why, but if you would, let us know. Anyway, all kidding aside, thank you, everybody, stopping the stream, and we'll be back in just a second.